Okay, and I said okay again. There has been some conversation online regarding how my circuit is functioning, and I have updated my schematic and gotten a fresh printout. And basically, a lot of what the conversation is centering on is my PNP transistor usage right here. Now, there, to begin with, apparently I got my pins wrong. The data sheet that I was using had the pins labeled in a non-conventional way, whereas most of the other data sheets have things set up more in line with how everybody else does it. The data sheet that I went by was the one that was provided by Mouser when I purchased the transistor on the internet. So now it looks like what I have is I have my emitter connected to my hot, my collector is going into the op amp and the capacitors, and then of course my base is connected to the first op amp. And so as far as the capacitors discharging, it may be that a lot of the capacitor discharging that we're observing is coming from the leakage current from the op amp, kind of keeping them from discharging. As far as how I have it set up on the breadboard, the transistor is right here, and the metal side is facing downward from the camera perspective. The leftmost pin I have connected to my regulated 12-volt supply. The middle pin is what I have going into my op amp. So this would be the pin on the left, pin in the middle, and the pin on the right is for my other op amp. And then the metal side is facing downward. And so, yeah, now there's been a lot of discussion over what would have the usage of an NPN transistor, and thankfully I do have an NPN transistor on hand. Not exactly by any stretch of the imagination what I have here. Now what I'm going to attempt to do is just a straight drop-in replacement of the one transistor for the other, and then I'm going to evaluate how the circuit's functioning and see what's going on, just to see if it still functions, and then maybe probe around a little bit with the multimeter. And let's hope nothing blows up and we don't have any magic smoke. Okay, so nothing. So far, so good. Nothing's on fire. Okay, let's try heating this up. See if the fan turns on. Turned on real quick. Still running. Still running. And turned off. Okay. Well, using a PNP resistor as a straight drop-in right there apparently works just as effectively, and it may be better. Kind of concerned that that one is just so small. And let's poke around a little bit with the multimeter, see what's going on. And let's see, now this right here is a probe point that I have for the input to the op amp. Right now that's at about 4 volts. Not sure if the camera can see that. Okay. Jumps up to 3. Or I'm sorry, it jumped up to 5. It came right back down. Alright, so now let's see what my other input is here. So that's 4, so whenever this jumps above 4, it should turn on the fan. Use a better mount probe point. Okay. Oh, and that drops back down to 3. So now I'm not seeing the discharging behavior from my capacitors. And it could be because there's no load in there. And also one thing I want to see is what happens when I only use one capacitor. Okay. And that just kicks right back off. Okay. Now that is interesting. When I replace the PNP transistor with an NPN transistor, the circuit still works, but I lose that timing. And I'm not sure if this is being seen on the camera, but here's the fan. And measure the voltage here, which is coming off the transistor and into the op-amp. Well, if I can get a good holding point on it. There we go. So yeah, that's 3.5 volts. Now when I warm up my thermistor, and the fan turns on and it goes up to 5.3 and starts slowly coming down again. Now that is kind of interesting because if that pattern continues, after a set amount of time, my fan should turn off. And let's see here. It'll take a while. Hang on. There we go. Seems to have leveled out. No, still going down. Okay, so then let's just take the capacitor out of there completely. Okay, now my fan's still going. Yeah, there we go, it stopped. Okay. Now that's interesting. I cooled it down and it seemed to run for a while. It's pretty high there. Discharged pretty fast. And this could have been due to the amount of time that the fan was running. I have noticed that with the PNP transistor, let it run a while to get all the way up to fully charge those capacitors. If you just kick the fan on and then kick it off real quick, the capacitors don't have enough time to charge up, and so it'll stay on for a shorter amount of time. Okay, let's see if that's kind of what's going on here. Does not appear to be the case. At least when I have the multimeter probes on it. Could be I was discharging it with the multimeter. So I'll let this run for a while. Let it cool down. And it's running the fan for a while. Decent amount of time. And it stopped it. Now I'm just going to let the fan run a little bit. Okay. So it seems like with the NPN transistor in there, it's a bit more responsive. Now I'm wondering, well, firstly, if I can adjust the set point. So let's turn this quite a bit. And what that has done has altered what's coming out there. So that's now up to about 12. And usually hangs around. So now the capacitors are still discharging. Okay. But that's off because it's tuned. Oh, no. Just holding steady at 4.7. Okay, so it looks like the capacitor could still be discharging. So if I turn this the other way, I should get my fan. Yeah, my fan kicks back on. Okay, so to the left is shorter, to the right is longer. And I get that down to 0, and of course it'll never kick off. So if I pop out my capacitor, my fan should stop. Hello. That's interesting. Why is my fan still running? Okay, that's still a set point there. Okay, it could just be that I have the op amp tuned improperly. Yeah, that's what it looks like. So, coming off the transistor, I have 351, so that's in the off state, 3.5. And I really should just poke another little wire in there so I can measure the other op amp. Okay. So right there I have 351 on the potentiometer. I have 6. And that's with it off. So with no capacitors, if I wanted the thing to turn on, huh. That's interesting. Oh, wait. Okay, so that's at 5 now. Sorting things out. Okay, so that's at 3, about 3.5 when it's off. And 5, 2 something when it's on. Okay. So that adjusts the on-off time there, but I've now... yeah, now I have no timing component. So yeah, the capacitors are required for the timing. So, put one of the capacitors back. That's nice, it wasn't even connected. There we go. So put one of the capacitors back, and now my set point hasn't changed, but it takes longer for that thing to turn on, and when it stays on, it'll keep running for a while. So that capacitor is indeed having a role to play in keeping this charged up, keeping the op-amp input railed a little high. And when it's charged, let's see, what did I do there? I got something running and I didn't mean to. Probably tapped the wrong thing. Okay, so yeah, when it's discharged right there, holding 3.5, and that's what we saw when it was off before. So you can't go below really 3.5 here. Okay. And of course, holding on to this with the multimeter causes the capacitor to discharge more rapidly. Okay, so yeah, that takes capacitor up to 5.3 there. Now, this is interesting. The capacitor, okay, when I have the NPN transistor in there, I put the capacitor in there and I don't see a continual voltage climb on the capacitor. And that's kind of what's going into it. And I can show you the difference here. So it's turned off, and I don't need this anymore. At least not for now. Come here. Okay, so it's in the off state, and I got 3.48 volts reading on that op amp. Waiting for the capacitor to charge. And in the on state, I have 5.3 volts, and then it starts dropping. Okay? Now, with the PNP, we're getting different behaviors. With the PNP, in the off state, I get 0. And this might be because I'm just grounding my capacitor at this point. Well, there we go. So, the capacitor charges up, and it'll hold a much higher voltage. And we can see that momentarily on the multimeter. See, it's getting up to about 9 volts. And then when it switches to the off state, that voltage drops, and that's what allows my potentiometer for my my inverting input set point to act as a timer, because this capacitor, taking a period of time to discharge and ramp down, is what allows this second portion of the circuit to actually work the way that I've set it up to work. So in terms of using the PNP transistor in this application, it appears to me, from what I'm seeing on the breadboard, by switching out the components and trying different suggestions that have been offered on the forum, what I have on there right now, going back to what's in this schematic, is what I'm needing for this circuit to function the way I'm wanting it to function. So the question really then isn't so much which components do I have on there, and it's not so much, does it do the job, it's how is it working this way, and what is causing the behaviors that we're seeing. Because from my original schematic, or from my original idea, what I was believing would be happening is that the op amp on the left, when it railed low, it would allow current to flow across the transistor from VCC to the capacitor and the input for the other op amp. And what I am now learning is that I appear to be running this capacitor in a reverse active mode, and the reverse active mode, it is basically flowing the current across the capacitor backwards. And I was not aware that, yeah, you could use capacitors going backwards, but yeah, you can. It's just that the voltage gain, or the current gain, not the voltage gain, but, well, sometimes the voltage gain, but the current gain that you're going to be getting across the transistor is going to suck. And this has to do with the doping between the positive and the negative regions in the capacitor. And one of the people on the forum was kind enough to link to a video that's going over some of it, and I have begun watching that video. Before I could actually get to the video he linked to, I had to go check the YouTube channel for the user and get some preliminary data, or watch some videos that were leading up to that, that discussed diodes, and which were pretty informative. So yeah, now knowing how I have this transistor connected, and what I'm going to do is I'm going to pop it out of the breadboard, and I'm just going to lay it out. So yeah, boop, there we go. So yeah, from this transistor here on the metal, what I have from my perspective is the pin on the left is connected to the VCC, and we can see that with this jumper here. The pin in the middle is connected to the op amp and the capacitors, and that's this black wire and this also this capacitor. So the black wire here is running to my op amp, and then I have the capacitor going across the center line of the breadboard in series to another capacitor here, and then a connection to the ground. And I put a connection to the ground in there to give myself a nice little spot to get in with the multimeter. The pin on the right is being connected with this orange wire to the output of the op amp here on the left. Okay, so that's how I have this PNP transistor set up on my breadboard. And looking at the data sheet, it appears that I have then the emitter, collector, and base going from left to right set up that way. Okay, so that means my emitter would be connected to the hot, my collector would be connected to my op amp output, and then my base, or I'm sorry, my collector is connected to the input on this op amp here, and then my base is getting the signal from the first op amp. So yeah, this transistor is then running in reverse active mode, so basically it's running backwards, and that explains why instead of getting the full 12 volts coming across here in saturation mode, I'm getting between 0 and 1. And when I discovered that, I figured, hey, go with it, work with it. Threw in an extra capacitor on my design, everything worked the way I'm wanting it to. So hey, as far as taking, this, a couple of different things that I saw on the internet and then combining them and adapting them for my own purpose, that's going well. That works. The understanding of why this is doing, or why this is behaving the way this is behaving, that is something that we should continue to explore. So yeah, let me put my transistor back there. And let's see here. Yeah, pin on the left of the hot. And it looks like I might have had something kind of funny going on. So yeah, that's right there where I was told that the op amp here is somehow powering the capacitors. That appears to somehow hold true. Oh wait, the leakage current from the first op amp, that's why. Okay, hang on. I was kind of wondering, why did things just start there? So anyway, the capacitors got charged because for some reason they weren't being grounded. And that's another interesting thing. If I take out that transistor, these capacitors will charge. When I put them back in, it'll then start the capacitors to discharging. So what I'm thinking is going on there is I just had some kind of leakage current from this second op amp, because if this transistor was not in the picture, there was no possible way for a leakage current to be going from this op amp to these capacitors. The only positive electrical connection would have been coming from this op amp. So that's an interesting thing. But either way, circuit does work as intended, and I can't help but come back to the redneck adage: if it's crazy but it works, then it ain't crazy. That may be the deciding factor on whether or not I use this in anything. But for right now, however, it's doing everything that I want it to exactly as I'm intending it to do. So I think that's great. And I would continue to appreciate feedback and input from the people on the forum. It could very well be that the only real correction that I need to make, or at least a correction that's needed, is what's going on with my schematic to accurately communicate to other people what we're doing. So anyway,
Thank you. Take it easy.